Hello, fellow algebrists. Today we're going to talk about some binomial expansions and especially what to do when the power starts getting big. If we were doing a problem more like this, what's the fourth term of x plus y to the sixth? You might think to yourself, easy money. I'm going to just check out Pascal's triangle for row 6. That'll give me my coefficients, and I can say, all right, so this is my a, this is my b, and so it's going to be x to the 6th, and then the power of this just counts down each time. X to the 5th, x to the 4th, x to the 3rd, x squared, x, and then no x. So this is x to the 1, this would be x to the 0. And then our y would be y to the 6th here, and then it would count down as you go backwards. Y to the 5th, y to the 4th, y to the 3rd, y squared, y to the 1, and y to the 0, and then put a bunch of plus signs in between them. That would be the entire expansion, and the fourth term would be this guy right here. But that process can get pretty hairy when you're looking at the 15th power. I mean, Pascal's triangle down to 15 rows is going to take up like your whole paper. So is there a more concise way? I don't want to say an easy way, because I don't think the binomial theorem is easy, but it can save you some time and some space if you get used to the binomial theorem. So let's take a look at the binomial theorem. And we're going to look at it in terms of this expansion that we just did. This one that was a little bit easier than the 8th term of whatever we're looking at up here. And so the binomial theorem gives you the binomial expansion for any power by doing this summation, and it uses a combination here, n choose k, which n choose k is really just n factorial over k factorial times n minus k factorial, which is really a lot simpler than what it looks like right there. Right there it looks really weird. It really is a lot easier than that, and I'll explain how to do that in just a moment. But so the binomial theorem gives you every term of an expansion, as long as you know what a is, and what b is, and what n is, and what k is. And k is just an index that walks you through every term of the expansion. When k is 0, you're going to plug in a 0 for k, right? N is always going to be whatever power we're dealing with. In this case, it's going to be 6. And k is just going to walk through. For the first term, k is going to be 0. For the second term, k is going to be 1. And you can see that working if you look right here. B to the k, right? So in this case, we got a is x and b is y, n is 6, and when k is 0, so if the first term k equals 0, so we would put a 0 in here, so b to the 0, or in this case it would be y to the 0, and that's why the y doesn't show up, because y to the 0 is 1, and x would be to the n minus 0, and n is 6. 6 minus 0 is 6, so that's why we got the 6th power here. For the second term, k would be 1, and you can look, if you look at the power of your b part, the power is 1 here. Here the power is 2, and k equals 2. Here the power is 3, and k equals 3. K equals 4. K equals 5. K equals 6. So your k value is always going to be the exponent on your b part of each term. So if you have a binomial to the 6th power, you're going to have 7 terms, and k is going to be the term number minus 1, right? This is the first term, 1 minus 1 is 0. This is the second term, 2 minus 1 is 1. So your k value is always 1 less than the term number. And so that's really the Rosetta Stone sort of for figuring out a given term using the binomial theorem, is because you're going to know what a is, you're going to know what b is, you're going to know what n is, and you just have to be able to remember what k is. And so let's just really quickly, for the fourth term of x plus y to the sixth, we want the fourth term. So that means that k is going to be 4 minus 1, so k equals 3. So here's what I'm going to do. I'm going to just do the third term here. I'm just going to do this for when k equals 3. So we got n equals 6. We got a is x and b is y. Okay, so n choose k. That's 6 choose 3. Remember, we're going to use this right here in just a second. I'll show you how not crazy it is. A to the n minus k, so that's going to be x to the 6 minus 3, which is 3. And then b to the k, so that's y to the third. Okay, so we're pretty close, right? We already got the x to the third and the y to the third. So how does 6 choose 3 get us 20? Well, it's going to be 6 factorial. So that's 6 times 5 times 4 times 3 times 2 times 1 over k factorial, which is 3 factorial. So 3 times 2 times 1 times n minus k factorial. So 6 minus 3 is 3, so that's going to be a 3 factorial. 3 times 2 times 1. So the n minus k factorial is always going to cancel out with basically the end, the last part of the n factorial, right? 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 is 1. And now we're going to look for other things that cancel out, and I know that 3 times 2 is 6, so these two will cancel this one. And what do I have left? On the top I have 5 times 4 is 20, and only 1 on the bottom, so 20 over 1 is 20. So that means that 6 choose 3 is 20. So 20 x to the third, y to the third is our fourth term. Alright, so now let's use this information that we just talked about to figure out the eighth term of x minus 2y to the 15th power. So in this situation, a is going to be x, b is negative 2y, n is 15, and k is the term number minus 1. So we want the eighth term, so k is going to be 8 minus 1, 7. So we need to do just this part right here. N choose k. So 15 choose 7 times a, which is x, to the n minus k. So 15 minus 7 is 8. And then b to the k. So b is negative 2y. To the k would be to the 7th. Okay, now off to the side I'm going to do 15 choose 7. So that's going to be 15 factorial over 7 factorial times, let's see, n minus k. So 15 minus 7, or 8 factorial. So that's going to be 15 times 14 times 13 times 12 times 10 times, I forgot, 11 times 10, 9 times 8, and now I'm going to do a little shortcut here, which is instead of writing 8 times 7 times 6 times 5 times, I'm going to write 8 factorial, right? Because 8 times 7 times 6 times 5 all the way down is 8 factorial. Now I don't have to write out this 8 factorial because they're just going to cancel each other out. And then the 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, and I need to look for stuff that cancels out. I know that 7 times 2 is 14, so the 7 and the 2 will cancel out the 14. 4 times 3 is 12, so these will cancel out. Let's see, 6 gazinta, let's see, 5 and 15, right? 15 over 5 reduces to 3 over 1, So that'll leave me a 3 and a 1. And then I've got, what else do I have? 10, I've got a, okay, so I have 6, which is 2 times 3. And I've got a 3 here, and then 10 is 2 times 5. So this 6 will cancel with this 3 times 2. And then what do I have left? I've got 13 times 5 times 9. So 13 times 5 times 9 is 585. Uh-oh, silly me. Look, the 11 kind of looked scratched out, but it really wasn't. So I have to do 13 times 11 times 5 times 9. And so that is 6,435. And now I'll show you a little shortcut. If you look under Math, Probability, NCR, that's N choose R, and you can do 15, choose 7, and it'll do all that for you, and you get 6,435. So 15 choose 7 was 6,435 times x to the 8th times, let's see, what's negative 2 to the 7th power? Negative 2 to the 7th power is negative 128. So this is times negative 128y to the 7th. And now I just need to multiply my coefficients here. Negative 128 times 6,435 is negative 823,680. So the 8th term of x minus 2y to the 15th is negative 823,680 x to the 8th y to the 7th. Ding! Thanks for playing, and I'll talk to you later. Ta-ta!